Welcome to the second section of the Drive Electric Tennessee Local Government Playbook chapter on developing fleet electrification plans. This section is specifically focused on public transportation, including the electrification of both transit buses and school buses. Cities across the U.S. and here in Tennessee are seeking opportunities to transition their existing bus fleets to cleaner, more efficient fuel sources. Zero tailpipe electric buses provide safer public transportation by producing significantly less carbon emissions and reducing harmful air pollution in our communities. Electric buses have considerable maintenance and fuel cost savings as compared to combustion engine buses, even though their upfront purchase price is higher. Additionally, the price of electric buses is falling fast with advancements in battery technology, greater manufacturing, and product availability. While electric transit and school buses have many similarities, there are enough differences in how they are driven, price points, and how they interact with the grid that we are going to discuss the two individually today. First, let's talk about transitioning transit buses. Transit buses are typically driven year-round. Because of their intensive service cycles, the use of an electric transit bus can result in significant fuel cost savings. With zero tailpipe emissions, electric transit buses can also play a huge role in reducing emissions, improving local air quality, and reducing disparate health impacts from diesel exhaust and particulate matter. In the Southeast, an electric bus provides for up to 3 times less CO2 emissions than a diesel bus. For reference, the typical transit bus achieves 4.8 miles per gallon, while an electric bus achieves the equivalent of up to 11 to 15 miles per gallon. Because of this efficiency and reduced maintenance needs, the overall lifetime costs of an EV bus are near the same as a diesel bus, despite the higher upfront cost. However, despite progress, electric buses are still roughly twice as expensive as diesel alternatives and can create a challenging point of entry to ownership. Financing mechanisms such as battery leasing options can allow customers to purchase the vehicle while leasing the battery, making electric buses even more accessible by lowering upfront purchase costs. Additionally, federal programs such as the Federal Transit Administration's Low-No Emissions Program and state programs such as the Volkswagen Diesel Settlement Environmental Mitigation Trust can also help reduce the upfront cost of electric transit buses, improving the business case for converting to electric. Working with your electrical utility provider is key to addressing charging infrastructure, and transit agencies will need to determine whether they want to install depot charging or en-route charging based on vehicle route design, cost, and feasibility. Additionally, with proper planning, transit agencies also have the option to develop fast charging hubs that can be used not only by transit buses, but also by light-duty vehicles, other municipal fleet vehicles, and the general public. These charging hubs can be useful community resilience assets in times of emergency, particularly if they are supported by distributed energy resources such as solar and on-site storage. Now, let's talk about school bus electrification. The U.S. school bus fleet is the nation's largest public transportation fleet, moving more than 25 million children on 480,000 buses each school day. One major benefit of electrifying school buses is a significant reduction of children's exposure to harmful pollutants and diesel exhaust from conventional buses. School buses have predictable schedules and large energy storage capacity, opening up opportunities for partnerships with local utilities and making them ideal candidates for electric vehicle-to-grid technology. Vehicle-to-grid technology enables bus batteries to provide power to the electric grid while not running, helping to offset demand during peak hours and increasing resiliency by acting as a stored energy source during an emergency. Additionally, school districts can more easily electrify their light-duty vehicle fleet and provide charging in their parking lots while combining site improvements for electric buses. In addition to electrifying transit buses and school buses, there are many private transportation companies that have developed creative electric solutions to address last mile and local transportation goals. Some examples include airport shuttle buses, last mile delivery vans, off-road utility vehicles, and rapid response vehicles. Looking forward, let's talk about a step-by-step strategy for electric conversion, which can apply to both transit and school bus fleets. First, a plan needs to be developed. Convening partners who will be essential in developing an EV transition plan, such as a school district's or transit department's fleet manager and leadership, the city's sustainability staff, your local power distributor, and representatives from a city's transportation department if relevant. Once the partners are convened and committed, then the following steps are suggested for developing a plan. Gather and analyze data on vehicle routes, service cycle, and range needs, fueling frequency, grade of terrain, and any other relevant local considerations. Next, conduct a physical infrastructure inventory and work with the local power company to identify any electrical infrastructure upgrades that would need to occur to support the installation of charging infrastructure. It's important to discuss charging infrastructure rates and tariffs with the local power company in order to better understand potential fueling costs, as well as options that can mitigate against potential demand charges, such as a favorable time of use rate. It's also helpful to research current and projected availability of electric vehicles that can meet the service cycle demands of the fleet. Consider life cycle costs of converting to EVs, such as impacts on maintenance operations, staff training, and availability of equipment if needed. Because the transition of a bus fleet has both environmental and health benefits, another suggested step is to calculate or model health and environmental impact goals for the conversion. These outcomes will also help strengthen funding requests. You can also identify best practices from other cities with successful transit or school bus conversions, as well as organize opportunities for conversations with peer contacts in these cities to understand their takeaways and lessons learned. Lastly, you'll want to identify any funding or financing opportunities that the municipality could pursue to help offset upfront or incremental costs associated with a new vehicle or infrastructure purchase. Finally, you'll want to develop an implementation plan for the actual fleet conversion, including an analysis of the total costs associated with the transition, such as the price of the buses themselves, any potential purchase incentives, charging infrastructure, maintenance, training, etc. Consider a timeline. Will you want to transition in segments, conduct a pilot, or otherwise? Will you have a conversion percentage goal that you will want to achieve by a certain year? Consider any additional policy changes needed, such as formal commitments to electric vehicles, carbon reduction plans, and/or air quality improvements. And identify any potential unforeseen risks that may require mitigation. As you and your partners move forward, it's important to ensure the following things are accomplished. Determining the acquisition and procurement strategy. Will you pursue a joint procurement? Will you lease the vehicle or purchase, or otherwise? Develop charging and refueling infrastructure. Work closely with both your local power company as well as the vehicle manufacturer or OEM to determine the right type of infrastructure to install, as well as the strategic locations for installing such infrastructure based on route design and a process for reporting continuous performance measurement, including health and environmental outcomes. One of the most important components in all of this will be funding. Although there are federal and state funding opportunities that local governments can apply for, having a conversion plan in place and the research done on the front end will be instrumental in supporting a successful grant application. We hope this session has been helpful as you consider your path toward a cleaner, more efficient electric future. You can visit driveelectrictennessee.gov for more information and sign up for the newsletter to stay updated on new technologies and funding resources available to assist you with your fleet conversion. Until then, stay tuned for the next session from this series on Drive Electric Tennessee.